The marine ecosystems in the oceans produce oxygen at huge levels, and half the oxygen we breathe comes from plants that are growing in the ocean. So even though the Arctic oceans are very cold, and we usually associate cold weather with not a lot of conditions that are not suitable for life, what matters in many cases, or one important factor, is the amount of light that's available. The amount of light determines how much photosynthesis can happen, how well can plants grow, assuming that there are enough nutrients around for those plants to grow. In the Arctic, during the summer months, there is a lot of light available. Once you're above the Arctic Circle, there's light available all the time during the summer. And that drives a strong photosynthetic community that in turn feeds the rest of the food chain.
It's the amount of light, the amount of nutrients, the physical environment that allows the productivity to take place. In a relative sense, the Arctic Ocean is a very small ocean, but it accepts a huge amount of fresh water.
Think about the Arctic as a Mediterranean, so an ocean surrounded by land. We have a lot of rivers coming into the Arctic, and the Mackenzie being the biggest on the North American continent, but then a few that are much bigger in terms of volume outflow on the Russian side. So all these rivers bring in a lot of fresh water, and this fresh water contains a lot of land plant material. And so overall, over the last years, there's more of that because the permafrost is melting, and the river runoff is what we call it, the water that comes in, has increased. So with that comes a lot of this terrestrial plant food, land plants. And so the paradigm has been, well, land plants can't really, or parts of them can't be broken down and utilized by marine organisms. So it's basically useless, but there's plenty of it, at least in coastal areas.
So we want to know how that's going to change how energy flows through the food web. It might have implications for polar bears, for walruses, for whales, if those energy flows are affected by this new input of land-based carbon.
Ecosystems in the Arctic Ocean are finely tuned to energy budgets. Energy is a limiting factor, and climate change is expected to bring with it an increased amount of heat, increased energy budgets that may alter the way these Arctic ecosystems function. There's going to be more thermal energy that may not be really accommodated for in current Arctic ecosystems.
We're already seeing differences in distribution of certain animals, so it's almost, at this point, we're trying to catch up with what we're already seeing happening. And it's an unfortunate place to be in, but luckily there's big research efforts that are going into that.